Good afternoon, everyone. So biodiversity and structural engineering. So just a sense check, I guess, this phrase biodiversity. In simple ways, it's the diversity of life. So it's species, it's wildlife, it's fungi, invertebrates, butterflies, but it's also just the water environment as well. And it is everywhere. Biodiversity is all around us, particularly in the work that we do in terms of engineering. Well, why is this important? Well, it's important for its intrinsic value, but it's also important because it gives us services, clean air, clean water, medicine, food, as well as we've just heard from the brilliant last talk, the materials we need to function as an industry. The problem is, though, it's in decline. It's in rapid decline. And I just want to bust one of the urban myths, because if you read the narrative on why biodiversity is in decline, often a lot of people talk about big, bad development taking up our green spaces. But it's important to recognise that actually, for so long, development's been given consent with some aspect of biodiversity loss. Now that's the system, right? So it's not development, that's the problem. Development goes through ecological impact assessments and EIAs, and there's all this insignificant losses which are actually starting to mount up. And every time our projects do more damage than they do good, the Earth takes a hit. And I don't know if anyone's noticed, but planet Earth is starting to pay back. She's keeping score. And those extreme weather events are now becoming all too familiar to us. And those extreme weather events that would never happen on our shores here in the UK are indeed reaching us. So it's time to change. And change is happening. Here in England, we have the Environment Act. It was enacted 2021, and it is bringing in mandatory, what's called Biodiversity Net Gain. So net means that overall there's a net gain in biodiversity. There's a measurable outcome where our projects do more good than they do damage. And how do we measure that? Well, there's a biodiversity metric published by Natural England, and it scores different aspects of habitats. So whether they're trees or grassland or shrub, how much we have, the location, the variety within that habitat. It scores them up, and the currency is habitat units that we compare before and after works. Now, to achieve mandatory biodiversity net gain in the eyes of the law, you've got to get at least 10%. So the magic number is 10%, and that's secured for at least 30 years. Now, there are delivery options. The creation or enhancement of habitats to achieve net gain can be on or off site. So change is happening, but it needs to happen faster. And I really echo the last speaker when she said everyone can play a part, because I think it's interesting to think, well, what role can structural engineers take? And I'd like to highlight 3 key actions. There might be situations where, for structural engineers, they get involved in assessing site suitability for construction. We've certainly had that. I worked for Balfour Beatty for many years on construction, and we would certainly have that interplay with our structural engineers that would come to site and work with us. At that moment, we all have a part to play in terms of, can we avoid the highly ecological value habitats and features? We can all raise it. We can all ask the question. Because if we do that as early as possible when we're planning work, when we're designing work, it simply makes business sense. Yeah, the way the metric works with biodiversity net gain, the more habitat you clear, the more you get into deficit, and the more cost you've got to pay to get back up to neutrality and then get to net gain. And I was working with the site, and it was a bridge going in. And one of the engineers was talking about, well, look, the temporary works footprint is probably going to be here, it's probably going to be here. And he knew that I was interested in biodiversity net gain. That afternoon, he sent me a plan going, look, I think if we arrange this and we can talk to the construction team, I think we might be able to save this line of trees that you've talked about was really important for bats. And it's in those moments. Biodiversity net gain, it's a team sport. If everyone can bring their ideas to the table, that's when we truly win. So number one, assessing site suitability for construction. Ask the question, can we avoid the high scoring habitats in the first place? Number two, I think it's such a fast moving and really interesting space in terms of questioning the buildings and the bridges that we build and say, well, can they be green? And I've worked on some tremendous project with green bridges, green walls, green roofs, brown roofs, internal landscaping. It's not just the outside that people green up, it's the inside as well. And often it will start with an idea, a spark, a discussion. And it truly then merges into something. The technology that we have now is far beyond anything that we had a couple of years ago to be able to do this. And the supply chain is really responding with those innovations in how nature can find a space in what we build. So my advice is engage. It's a team sport, Biodiversity Net Gain. So engage ecologists and landscape designers. Say, well, how can we make this green? But also what's important at this stage is to be open and upfront about the challenges when you do green up a typically grey structure. We were working in Birmingham and we had some really great engineers on board looking at ways to green up one of the main bridges throughout Birmingham. It's where the trains come in. And the challenge was vandalism. And it looked like, in all honesty, that we'd have to put this massive security fence in front of the green wall in order to stop the vandalism. And that was a big challenge. You can't just have something looking like it's some American sci-fi movie in front of a green wall. But we engaged early with the right specialists, with the security specialists, and we came up with a solution. It wasn't the ideal in terms of the full green wall, but there were areas high enough that we could green up outside of the reach of vandalism. So engage, have that idea, have that spark, talk about the challenges, because there will be challenges and how these can be overcome. Just to highlight why this is so valuable, I mentioned the Environment Act, and there's a metric, a biodiversity metric that measures habitats, and you compare it before and afterwards, and then you get to your 10%. The habitats that I've just mentioned feature in the metric. So every time you might think about a green roof or a green wall or street trees or green bridges, you directly contribute to biodiversity net gain. It features in the metric. So engage ecologists and landscape designers, talk about biodiversity net gain and just talk about what the possibilities might be. And it doesn't have to be creating something new. If you do, and if you can engage ecologists and landscape designers, particularly for ecologists, ask them, well, look, we're building a bridge here. Can I ask you, is there any nature that's down and out, that's degraded, that's kind of inherently valuable for nature, but it's not doing too well? Because there might be a way that we can enhance it. Enhancement, restoration of nature is fundamental to our targets for conservation. The nature recovery, that's the point. We're living in a degraded environment that we've created. So as well as creating those innovative designs, the green bridges, the brown roofs, search for degradation, the hedgerows, the scrub, the woodland that are in need of some help. And how can we do that through our designs? My final point, and really to echo the last speech about circular economy, is, okay, biodiversity net gain, that's the direct site footprint, right? That's the change in habitats before and afterwards, and what green habitats can we create through our design. But that's the starting point. It's not all of our impact on nature. And the materials that we select and we procure, the supply chain that we use, all of that has an impact on nature. So I strongly echo and really encouraged by the last talk about understanding what that impact is on nature. What I would add, though, is in my world, we set a measurable target. So when you look at your impacts on nature through the materials that you select and you procure and your supply chain, that target is called nature positive. And it is a fast emerging, exciting target. There's a global goal for nature. It's been coming out for a while and it's just gaining momentum. You see there the dip where we are. to get back up to that point of where we were back in 2020 by 2030, and then we can get net positive for a full recovery by 2050, and that's the challenge. So it's not just about the habitats that we create, it's understanding through selecting and procuring materials, we have a global impact on nature. And if we have a global impact, then let's make that a positive one. To add to the examples as well, yes, of course, there's things already in existence like the good old FSC, but that's not just it. It's every single material that we have. And I think it's a really exciting space for this world of structural engineering to grab nature positive. It's new, it's fast emerging, people are learning, people are exploring, people are questioning it, but we can make an impact through what we do now. So biodiversity, it's certainly a part of our world when it comes to structural engineering, through direct site impacts, through the teamwork, but also through thinking about everything that we do through materials to have that nature positive impact. Thank you very much.